So here is another question on simple harmonic motion equation. So it is given that the periodic time of a body executing SHM, simple harmonic motion, is 2 seconds. Okay. After how much interval of time from the initial time, from the start, that is at t equals to 0, will the displacement of that particle be half of its amplitude, that is maximum displacement. Okay, so first, in any kind of SHM related question, first you have to write the standard form of SHM equation. So y or x, whatever you want to write, y is equal to or x is equal to, whichever you want to write, it doesn't matter. Y is the instantaneous displacement, which is a sine omega t plus phi. A amplitude, the maximum displacement on either side of the mean position. Omega is the angular frequency, t is the instantaneous time, and phi is the initial phase. Here nothing has been mentioned about the initial phase, so we will take it as 0 radians. So this equation will become simply a sine omega t. Now, given that the time period is equal to 2 seconds, we know angular frequency is equal to 2 pi f, where f is the frequency in hertz or second inverse, which is equal to 2 pi by t, because f is equal to 1 by t. So here if we put the value of this time period, t is equal to 2 seconds, we will get angular frequency equal to 2 pi by 2, that is equal to pi radians per second. So this equation will become a sine pi t. Now what is asked in the the question, that we have to find the time interval where the displacement will be half of its amplitude, that is this value, instantaneous displacement, will be equal to half of the amplitude a, this a by 2. So we'll equate both sides, we'll use this equation. In the LHS we'll write a by 2, here we'll write a sine pi t. Okay, so a will get cancelled, that implies sine pi t is equal to 1 by 2. Now we have to find out a particular sine function, the value of which is equal to 1 by 2. So it is sine 30 or pi by 6. In degrees 30, in radians it is pi by 6. That implies sine pi by t, we can write it as sine pi by 6 in terms of radians. Okay, sine pi by 6 is equal to 1 by 2. So we have substituted 1 by 2 with sine pi by 6. That implies t, this here pi t is equal to pi by 6, pi gets cancelled, that implies t is equal to 1 by 6 seconds. So after a time interval of 1 by 6 seconds from the initial time t equals to 0, the position of the particle will be exactly at half of its amplitude. Okay, this the maximum displacement. Okay, so this is the. So here is another question on SHM motion, basic equation of simple harmonic motion. So it is given that a particle in simple harmonic motion is described by the displacement function x is equal to a cos omega t plus phi. So here it is given in cos. And it is also given that if the initial position at t equals to 0 of the particle is 1 centimeter and its initial velocity is pi centimeter per second, what are its amplitude and phase angle? The angular frequency of the particle is pi radian per second. So here first we'll write down the basic SHM equation, which is given in the format in the question, a cos omega t plus phi. Then we will use the information. It is given that at t equals to 0 second, the initial position of the particle x 0 at t equals to 0, that is equal to how much? 1 centimeter. So if we substitute the value here, that implies a cos omega, which is the angular frequency, is pi radians per second. Pi into 0, okay, plus phi, that is equal to 1. That implies a cos phi is equal to 1. Okay, this is an important relationship. We will put it in a box, give it a number. Then velocity, we know that is displacement by time, derivative of displacement function with respect to time. So that is here equal to minus a omega sine omega t plus phi, according to the equation which is given. Okay, dx by dt is minus a omega sine omega t plus phi. It is given that the initial velocity at t equals to 0, that is pi centimeters per second. So if we substitute the values here, that implies minus a pi, because angular frequency is pi, sine pi into 0 plus phi is equal to pi centimeters per second, this much. So here pi will get cancelled, and here it will be, that implies minus a sine phi is equal to 1, or a sine phi is equal to minus 1. Yes. Okay, this is equation number 2. Now, if we square equations 1 and 2 and add them, okay, on squaring equations 1 and 2 and adding them, we get a cos phi whole square plus a sin phi whole square is equal to 1 square plus minus 1 square. That implies a square cos square phi plus a square sin square phi is equal to 1 plus 1, which is equal to 2. Here a square will be common, a square plus cos square phi plus sin square phi, that is equal to 2. This whole thing is equal to 1 because sin square phi plus cos square, that is equal to 1, plus a square is equal to 2, that implies a is equal to plus minus root 2 centimeters. Magnitude wise it is simply equal to root 2, magnitude wise, okay, centimeters. That is the maximum displacement. Now that is the amplitude. This is the amplitude. Now we have to determine the phase angle. Again, dividing equation 1 with 2, okay, sorry, 2 with 1, okay, a sin phi by a cos phi, that is equal to minus 1 by 1. Here a will get cancelled, so that implies tan phi is equal to minus 1. So we have to figure out the quadrant in which tan function is negative, so it is all sine tan, so it will be phi, that will be equal to tan inverse of minus 1, so all sine cos, so yes, it will be 3 pi by 4. Yes, this second, yes, 3 pi by 4. That implies phi is equal to 3 pi by 4, which is the initial phase angle. Initial phase angle. So this is the initial phase angle and this is the amplitude which were asked in the question. Okay, amplitude and phase angle. Okay.